Hello everyone, my name is Manuel Pitt, and in this video we will talk about Aria automation config and how you can use reactors. I will show you how different components interact with each other and how you can set up a reactor in your lab. If you're already familiar with SaltStack, you might know those components, the minion, the master, and the RAS. When you want to use reactors, you need to do some configurations on those components. The first configuration has to be done on the minion. You have to deploy a beacon. The beacon is responsible to monitor your system events and forward those events to the master. The second configuration has to be done on the master. You have to modify your master conf or create a separate reactor conf file. This conf file is responsible to link an event to a reactor state, means which action should be taken when a certain event occurs. The last configuration you have to do is creating a reactor state. The reactor state is a state file which contains the action which is being taken when a certain event occurs. You can store your reactor states on the RAS file server, on the master servers directly, or on any supported external repository. Let's have a look on the dependencies between each of those components. One of the central components of the reactor system is an event. An event is sent from the beacon to the event bus of the master. In the reactor conf, I've said that before, we link an event to the reactor state. If a certain event occurs, the linked reactor state is being executed, and this definition comes from the reactor conf. Let's get started with our lab environment. I will show you first the configuration of the beacon. Second, I will show you the reactor conf. Third is I will show you the reactor state. And finally, I will show you what the reactor does when the service is stopped on our machine. So let's start with the beacon configuration on our machine. To check installed beacons, we have to run the command salt beacons list. This command will show us all of the installed and configured beacons running on our machine. In our case, we have two beacons installed, a memory usage beacon and a service beacon. The memory usage beacon is currently disabled. The second one is a service beacon, which is monitoring the HTTPD service. We will use the service beacon later to monitor the service and trigger our reactor to always restart the service whenever it is stopped. Next configuration we have to do is on our master server. We are going to create the reactor configuration. For this, log into your master server using SSH and navigate to the folder etc salt. Inside the salt folder, you have a file called master. This is the main configuration for your master server. Let's have a look into this and check if there is a configuration for our reactors. If you scroll a bit up inside your configuration, you will find a section for your reactors. Here it is. The reactor settings are in the master configuration, or you can also copy this part here and create a separate file called reactor.conf. This is the mapping between an event and a reactor state. The reactor state is, in our case, on our salt file server, folder reactor, and then the reactor state is called service.sls. Next step is to look into this service SLS. So what is our reactor state doing? For this, log into your SaltStack config UI and navigate to config, file server, and then depending where you store this file. In my case, I store it in my base environment. I have a folder called Reactor, and inside the reactor, I have the reactor state file service.sls. Inside of the reactor state, I define, let's say, three different things. I have a condition when this reactor should run. The condition is reading some information from the event. Data is the event data. Service name is an attribute inside of the data payload. Running is the attribute of the service, and I'll check, is my service running or not. If it's not running, then this condition is met. And I have a second condition here, which is checking if the service name is HTTPD. That's the condition when this reactor should run. Second is I define the name of my executed task, which is start service, and then I specify the action I want to run. So in that case, I say local.service.start. That's the module which runs a remote command on my target machine to start a specific service. I then define the target, TGT, which is my minion ID. Also, this minion ID is read from the event data, and I pass one argument to my execution, which is the name of the service I want to start, which is HTTPD. And then I close this entire reactor state with the closing of the condition. Save this and store this reactor file on your file server. Here's one additional comment on this reactor state. This command execution, local service start, including the target and the argument, can also be done directly from the master. For this, log into your master. Once you're logged into your master, you can execute the salt command, which is salt, your minion ID, then the module you want to execute, and the argument. In our case, it's the name of the service, it's HTTPD. When you have executed this command, you can check the execution back on your SaltStack config UI by going into the Activities tab, checking completed, and then you will see this event here. And you see it has started my service on my remote machine. So far, we have configured a minion which runs server beacons, in our case a service beacon. We have a Reactor configuration on our master server, which is linking the service event with the Reactor state, which is the service SLS. And on the RAS, we have, of course, our Reactor state. Once this is done, we can now move on to test our Reactor. For this, I will log into my target machine, stop my web service, and check if my Reactor is automatically restarting the web service. Last but not least, we will test our Reactor. For this, we will log in to our target machine and stop the web service, and in parallel, we will check the event log on the master to see what's happening. So let's start with the event log on the master. Log in to your master using SSH and run the following command. Salt run state event pretty equals true. This will connect to the salt event bus and list all of the events which are happening on our master. As you can see, many events are now popping up depending on what's happening in our environment. So let's stop the web service on our target machine. I stopped the event log because it's showing just too many events right now, but just scrolling back up to the very first event. Here you can see the first event sent by our beacon. At 12:33, the HTTP service was stopped, or better said, it changed its state into not running. Then, because of that event, we had a job started. If we just scroll a bit down, we see here's the service.start job started. The next event shows the job executed successfully. And if we jump back on our target machine and check when was our web service started again, it should be also 12:33. Et voila, as you can see, our web service was started at 33, so it was exactly when I stopped the machine, immediately the Reactor catched the event and started the web service again. You can also see this event on our SaltStack config UI by going into our activities list, checking the completed activities, and then see the last job which was executed was the service start at 2:33. In the end, this example should show you that a Reactor can catch an event very, very fast and act immediately. The limit of what you can do with the Reactor is basically your imagination. So you can react on many events, and the complexity can be very complex or as simple as I've done it here in my example with restarting the service. It's up to you. But It can make your environment more stable and let it heal itself. I hope you enjoyed the video. See you next one. Bye.
For more information, detailed videos and blogs about all Aria Suite products, please visit apps-cloudmanagement.techzone.vmware.com or simply scan the QR code to learn more.